All right, so let's look at this first one. We have a b to the negative 1 over 2b, and that is being multiplied by a to the negative 4 over b to the negative 3. All right, so this is all multiplication, all right? So because this is not being taken to some power, you can just think of it as your a times b to the negative 2 times a to the negative 4th over 2 times b to the negative 3, okay? Because all of that in the numerator is just multiplying, all of that in the denominator is just multiplying. So anytime I have these really complicated ones, I usually simplify all of my numerator and then simplify all of my denominator and then see if I can do my quotient rule, okay? So I am going to simplify whatever I can. Like I'm going to look at this a and I'm going to say, is there anything else in the numerator I can simplify that with? Well, yeah, right here. So I have a to the first times a to the negative 4th. So that's going to be a to the 1 plus negative 4, okay? Because I'm multiplying like bases. The b on top really doesn't have anything on top that it can simplify with. And then on the bottom, I have a 2. The 2 is going to stay there. And then I have a b to the first and a b to the negative 3rd. So that's b to the 1 plus negative 3, okay? Does everybody see that? Okay? And so 1 plus negative 4, well, that is a to the negative 3, b to the negative 2, 2 times b to the negative 2. Okay? So at this point, I go top to bottom because my top is as simple as it can be and my bottom is as simple as it can be at this point. All right, so my rule from top to bottom, I still have 2 of my b's. My rule there is to subtract. What is negative 2 minus a negative 2? It's 0. Anytime you have the exact same thing on top and bottom, b to the negative 2, b to the negative 2, those are always going to reduce to just 1. Always. 3 over 3, that's 1. 4 over 4, that's 1. X over x, that's 1. B to the negative 2 over b to the negative 2 is just 1, okay? So those are going to cancel out. And you have a to the negative 3 over 2. I still have a problem. I cannot leave a negative exponent. What did we say a negative exponent did? Where does it put it? Yeah, it flips it. If a negative exponent's in the top, it's going to drop to the bottom. If it's in the bottom, it's going to jump up to the top. So that means this guy is actually going to move to the bottom. We can never just have a bottom of a fraction. If everything moves to the bottom, you need to put that 1 up there at the top, okay? So when this canceled out, this technically canceled out to a 1. But even if it hadn't, if everything moves to the bottom in a fraction, you have to put a 1 on top, okay? And so that's how we got this one. So for 31, I'm still going to simplify the top and the bottom individually. If you look at the top here, though, it is a group to a power. So I cannot do top to bottom yet anyway, because I have to deal with this whole group taken to a power. And so I'm going to take each of the pieces to that power. I'm going to say a to the second power. I'm going to say b to the second power. And I'm going to say c squared to the second power. All right. And so this c squared to the second power, when I have a power to a power, what do I do with those? Yeah, I'm going to multiply. So I have a squared, b squared, c to the 4th over negative 3bc. So let's look at my pieces. For my numbers, I just have a negative 3. That's going to stay on the bottom as a negative. You'll notice they actually pulled that negative in front. It's okay. It can be on bottom or in front. It makes no difference. It's still a negative fraction. Let's look at our a's. Well, my a doesn't have anything to simplify with, and it's a positive exponent. So that's just going to stay where it is. A squared. Okay. Let's look at my b's. Well, my b, I have a b on top with a 2 and a b on bottom. So I'm going to say, well, that's b to the 2 minus 1. What is that? B to the first power in the numerator. So it's going to stay up there in the numerator. Let's look at the c's. I have c to the 4th power on top and the first power on bottom. That is c to the 3rd. That's going to stay there. All right. So a couple of things I want to point out here. First of all, when I got to this point, the a squared didn't simplify. With the b, I had 2 b's on top and 1 on bottom. Where did the b end up at? Top or bottom? Top. I had 4 c's on top and 1 on bottom. Where did it end up? Wherever the larger exponent is, that's where he's going to end up. Okay? Because if I were to do this by expansion method, so for some of you I will see it on your quizzes and tests, and that's perfectly fine. Some of you will live by the expansion method because it makes more sense to you. You could, at this point, expand it. I have a times a. I have b times b. I have c times c times c times c, right? On the bottom, I have -3, and I have a b, and I have a c. So you can literally cancel, right? And you see I have 2 a's on top. I have 1 b on top. I have 3 c's on top. And I have a -3 on bottom. So either method, whether you do the subtraction or whether you do the expansion, you're going to get the same answer. I will say expansion is going to take longer, okay? So that's why we have shortcuts, because it produces a pattern, right? The expansion is for pattern. But either way, you're going to get the same answer. All right, scientific notation. It is a number written in scientific notation when it is expressed as a product, a times 10 to the n power. The key here is that a must be between 1 and 10. Notice your greater than and less than signs, okay? Notice these guys, they're technically less than. This is less than or equal to. This is just less than. What that means is it can equal 1. It cannot equal 10. So it can equal 9.99999, but it cannot equal 10 or it is not considered scientific notation, okay? So it has to be between 1 and 10, inclusive of 1, not inclusive of the 10. And that's going to become important when we start putting these in scientific notation. Hopefully you have done scientific notation, and a lot of this will be review. So let's say we have this big old number here, and we want to put it in scientific notation. We have to first figure out where the decimal would go to make this guy fit in between 1 and 10. Well, if we put the decimal here, he's going to be 4.2. So that's where we're going to put the decimal. Whatever's going to make this guy between 1 and 10, we're going to put it right here. And then we just have to count. At that point, you can do it if you're in like K4, count, all right? So start from where the decimal was and count to where you're putting it. Well, I'm counting 1, 2, 3, 4, 5, 6 places, okay? So 4.2 is what made it between 1 and 10, and 6 decimal places is how much I moved it, okay? 6 decimal places is how much I moved it. So then let's look at this guy. This is a really tiny number. He was a really big number. This is a really tiny number, right? 0.0. So would you rather have this much money or this much money, right? Okay, think of it this way. So really tiny number. Same thing. This number currently is not between 1 and 10. So where would I have to put the decimal point to make sure he's between 1 and 10? Well, I'd have to put it between the 6 and the 7. 6.7. Now we're just counting. The decimal point started here. 1, 2, 3, 4, 5. So 5 is going to be my exponent. But you notice something different about this exponent. This is a negative, okay? Here's the thing. Many, many times I have had people say, oh, you move to the left when it's this, you move to the right when it's this. Let me tell you something. I promise you can do that if that helps you. But somewhere on a test, you're going to be like, is it left or right? Right. Okay, I'm serious, because whatever you come up with is going to sound right on a test. If you are going from a really big number to scientific notation, you should have a positive exponent, because that's what makes really big numbers, okay? If you are going from a really tiny number to scientific notation, you should have a negative exponent, because negative exponents make tiny numbers. They make fractions, okay? So don't try to remember left and right. You're going to get confused when you're nervous on a test. Try to remember really big number, positive exponent, really tiny number, negative exponent. Because it works both ways, okay? If I have scientific notation with a positive number, you should probably be adding zeros behind the number and making it really big. If you have a scientific notation with a negative exponent and you're converting the other way, you should probably adding zeros before it with a decimal to make it a really tiny number, okay? And so if you just remember that, you're gonna probably remember it better, okay? So let's look at some of these examples. Express these numbers in scientific notation. Express them in scientific notation. So the first thing I'm going to decide is where am I going to put my decimal? Where am I going to put this decimal to make it between 1 and 10? Right there in between the 2 and the 9. So it's going to be 2.95, okay? And then all I'm doing is counting. So my decimal started here, 1, 2, 3, 4. So that is going to be times 10 to the positive or negative 4? Positive, because this was a really big number. All right, let's look at the next one. Where am I going to put the decimal? In between what two numbers? 4 and the 3. And now I'm just counting 1, 2, 3, 4, 5, 6, 7, 8. It's going to be a negative 8 because that's a really tiny number. All right. You'll notice that I'm drawing a cross because if you just count without touching it, you're going to miscount. Between the 9 and the 5, I have a 29.5, which is not between 1 and 10. Has to be between 1 and 10. So 29.5 is bigger than 10, so I need to go one more place. So before we even convert it, let's look at A. Is A going to be a big number or a small number? Big number. It's going to be a big number, which means I want to add to this number. So I have the 2.1. If I go this direction, I'm going to be making it smaller, right? So I need to go this direction, make it bigger. By 5 places, I start here and go 1, 2, 3, 4, 5. And those little blank spaces, I'm going to put zeros. Right? And so now I have 2, 1, 0, 0, 0, 0. Count from the right over every 3. You're going to put a comma, right? Let's look at this one. First, is this going to be a really big or a really small number? It's going to be a really small number. So currently I have 6.8. To make this smaller, I've got to go this direction. If I do that, I'm going to have a really huge number, okay? So I'm going to take that and I'm just going to start here and count how many spaces? 6. 1, 2, 3, 4, 5, 6. This is where my decimal is going to go. And I'm going to fill these in with zeros. Right? And so that's my answer. My answer is 1, 2, 3, 4, 5 zeros. And then 6, 8. By the way, it will always be 1 less 0 than you moved because you should have a number in front of it if it's 1 to 10. We're doing all multiplication, right? So this is like 7.5 times 10 to the negative 5 times 2 times 10 to the third. Okay? Everybody agree with that? So if it's all multiplication, can I rearrange it? Well, yeah, 2 times 3 equals 3 times 2. So I can rearrange it. So I'm going to say 7.5. Oh, that looks like a decimal. That looks not like a decimal. 7.5 times the 2 times 10 to the negative 5 times 10 to the third. Okay? So we can do 7.5 times 2. 7.5 times 2 is just 15. Okay? So this is just going to be 15. I have like bases here. What do I do with my exponents when I have like bases? I add them. What is negative 5 times plus 3? Now here's the only time where you don't put it in the denominator, by the way. Scientific notation, leave it as a negative. Any other time I'm going to say positive exponents, but scientific notation you don't. All right? Is this, however, in scientific notation? It is not in scientific notation. Why not? That guy's too big, right? So where's my decimal? It's right here. Where does it need to be? Right there. All right? So I add one place to it because I moved it one place. So now I have 1.5 times 10 to the negative 1. Negative 2 plus 1 is negative 1. That is my answer. Okay? So it may look a little intimidating, but it's not too bad. Let's look at the next one. So I have something inside to a power. Okay, so this is a little bit different. Anytime I have a power to a power, I'm going to multiply. But when I have multiple things inside to a power, I have to take each piece of it to the power. So that means I need to do 1.2 to the second power. And I need to do 10 to the negative fourth to the second power. 1.2. What is 12 squared? 144, right? Right? 12 squared is 144, but it's 1.2. So I have two decimal places. So instead of 144, it's going to be 1.44, right? That's all you do when you square decimals. Just square the number and then figure out your decimals, right? What about this guy? Power to a power. What do I do with those? I multiply them. So this is going to be negative 4 times 2. So negative 8. Is this in scientific notation? Yes, it is. 1.44 is between 1 and 10. I'm done. This is my final answer for this guy right here. All right. Division. So I'm actually going to write this out. 2.4 times 10 to the 7th over 6 times 10 to the 2nd. And we're going to do this a piece at a time. So think of this as like 24 divided by 6. What is 24 divided by 6? It's 4, right? Okay, so normally 24 divided by 6 is 4, but I had one decimal place. So 2.4 divided by 6 is just 0.4. Okay, so that takes care of that piece of it. And now I'm dividing like bases. What do I do with my exponents when I'm dividing? Yeah, so I have times 10 to the 7 minus 2 is? 5. Is this in scientific notation? No. Is this number smaller than 1 or bigger than 1? No. Smaller than 1. So I am going to move my decimal until this is between. All right? But technically this was a smaller number that I'm moving to make bigger. So if it was a smaller number, I need to subtract that 1. That's a negative 1, right? So this is 4 times 10 to the 4th power. Okay, so we are adding these here. So this is a little different. You're not going to take each piece and add it. You actually have to factor out. So think about when we were doing distribution. Okay, we're going to use our distribution property here. And we are actually going to take out the common term here. So if we look at this part, we have 10 to the 6th, 10 to the 6th, right? And so we can actually factor that out. So that is 10 to the 6th. And I'm going to factor on this side. If I factor out a 10 to the 6th over here, I get a 2.3. And I factor out a 10 to the 6th over here, I get a 5. Okay? Think of it how we first started adding like terms, right? We first started adding like terms. If we had like 2.3x plus 5x, right? What would you do? Well, you would add those exponents because technically that's x times 2.3 plus 5, right? Does that make sense? And so that's basically what we're doing here. They have the same exact term there. And so I am going to just add these guys here. And I'm going to say, well, that is going to be 7.3 times 10 to the 6th. So for this one, I have a 10 to the 5th and I have a 10 to the 4th. All right. So this one is not exactly the same. Let's say we have 2 times 5 squared plus 3 times 5 squared. Okay. So by my theory, this should be 5 times 5 squared, right? Based on what I did over here. Right? Everybody agree? Based on what I said. Okay? You're asking why we would make this to the 4th power. Why is it not to the 4th power? Okay, if we put those numbers actually in, this is 2 times 25 plus 3 times 25, right? Which is going to be what? 50 plus 75. Okay, so far so good. Right? This guy is going to be way bigger than that. Like, this is going to be 5 times 5 times 5. Right? He's huge. They're not the same number. So what you're doing here is you're trying to actually multiply him twice. He's not being multiplied twice. Like, you have to think of order of operations here. So it's just like terms. This is 2.3 times 10 to the 6, just as like this is 2.3 times x. This is 5 times 10 to the 6, just like this is 5 times x. We don't have x squared at the end of this problem because we're adding 2.3 x's and 5 x's. We're going to get 7.3 x's. You're adding 2.3 10 to the 6's and 5 10 to the 6th. We're going to have 7.3 10 to the 6th. Make sense?
Yeah.
So if this were multiplication, that would definitely change to 10 to the 12th. Because you're multiplying a 10 to the 6th and a 10 to the 6th. But you're not multiplying 10 to the 6 times 10 to the 6. They're only being multiplied by those numbers. Okay? Make sense? Yeah. If you put in numbers, it doesn't work either. All right. So for this one, I can take out a 10 to the 5th. But then this guy's left kind of wanting, right? So what they basically do here is they say, well, let's rewrite it. Let's say we will have 5.4. We'll leave him alone for right now. Okay. Minus 4.7 times 10 to the negative 1.